All right, a couple of quick graphing problems. So we're going to graph -3 secant of 1/3 x plus 1. What I like to do with secant and cosecant is go ahead and graph my sine or cosine graph first, and then use that to graph. So I'm actually going to go ahead and do -3 cosine of 1/3 x plus 1 first. I scaled my graph in pi. I'll just mark that 1. I think that would be helpful. So the first thing we need to do is figure out the period of our function, our secant or our cosine function. So our period is 2 pi divided by the number in front of x. And the number in front of x here is 1/3, so I think the easier way to do it is actually this. Flip your second. So the period of the function is 2 pi times 3 is 6 pi. So one whole cycle of my function I'm going to have done in 1, 2, 3, 4, 5, 6. The amplitude is 3, and I'm reflected over the x-axis. So instead of starting at a max, I'm going to start at a min. I'm also starting up 1 unit from that plus 1. I'm going to ignore my x-axis and use that as my midline. So let's see, down 3 for my midline. I'm going to be back to that minimum value after 6 pi. 1, 2, 3, 4, 5, 6. Halfway in between, I have a maximum. That's going to be at 3 pi, and that's going to be 3 up from my midline. Halfway in between my max and my min, I'm going to cross my midline, so it's going to be 1.5. I'm going to dot in my cosine graph. I'm going to go ahead and keep this pattern going. Go in 1.5 boxes. Great, and now I'm going to put my asymptotes in. So my asymptotes for my secant function are going to happen where my cosine graph crosses the midline. So not where my cosine graph crosses the x-axis. And then my cosine curves go in the opposite direction of my secant curves go in the opposite direction of my cosine curve and share the maximums and minimums. Have some graph in there and right there. And that is -3 secant of 1/3 x plus 1. Keep in mind that you will be allowed to use your calculator on this portion of the test. So if you're putting this into your calculator to try to match the graphs that you're seeing, or to try to double check your answer, to put in secant, you would have to put in 1 over cosine. And then you would just put your 1/3 x in parentheses. You could put your -3 up top, or you could put parentheses around your 1 over cosine, and then you would use that. So it's going to look kind of funky, but see me in class if you need help checking that. 2 more quick graphs. Ooh, an absolute value of a cosecant graph. All right, so absolute value takes everything that would be below our x-axis and bounces it above. So what I'm going to do is go ahead and do the same kind of transformations for cosecant as I did for secant. I'm going to dot and sine, and then we'll do our absolute value of our sine graph and then draw in cosecant. All right, so really what we're going to graph is 2 sine of negative pi over 2. So first, I'm going to figure out the period of our function, 2 pi over 1 divided by pi over 2. 2 pi over 1 times 2 over pi. So our pi's are going to cancel, and the period of our function is going to be 4. The other transformations that we have going here, we have an amplitude of 2, and this negative in front of our pi over 2 is going to reflect over the y-axis. So instead of going up first when I'm graphing, I'm going to go down first for my sine graph. So I'm going to start at 0, 0. Again, right now I'm totally ignoring the fact that we're doing cosecant and totally ignoring the absolute value. One period of function happens at 4 units. Halfway in between, I cross my midline. Halfway in between my first two, I'm going to have a minimum since I have a reflection. And remember, for sine, a reflection over x and a reflection over y are both going to go down first and then up. And then between units 2 and 4, I'm going to have that. So there's one period of the sine function. To do the absolute value, anything below our x-axis is going to bounce up. So this stuff down here, not really there. We're doing absolute value. It's going to bounce up for us. And that pattern we can repeat in both directions. When we're drawing in our cosecant graph now, what we're going to do is dot in your asymptotes. So your asymptotes are still going to happen where your graph is touching the x-axis. Now, instead of having half your curves below and half your curves above the x-axis alternating, we're going to have all of our cosecant curves meet up with our little sine absolute value maximum. And this you can also check on your calculator. Maybe easier to check the sine version than the cosecant version. But again, to get 2 cosecant of negative pi over 2x, let's put 2 over sine of negative pi over 2x on your calculator. Y or f of x, depending on if you have an Inspire or an 84. All right, last trig graphing example on the review packet. Match the function cotangent of 1 over 13x. This problem is 100% about what the period of cotangent is. So remember, cotangent and tangent work differently than sine and cosine. Cotangent and tangent have a period of pi. So when you're trying to figure out what the period of your function is with a transformation, with cotangent, you're not going to do 2 pi divided by the number in front of x. You're going to do pi divided by your number in front of x. And I do think that it's easier for you guys. And so pi times 13. So if we're looking for a cotangent graph with a period of 13 pi, the other thing to remember about cotangent is cotangent has asymptotes where tangent has 0. So I know tangent has a 0 at 0, and if the period is usually pi, now it's 13 pi is what I'm looking for there. And cotangent is decreasing where tangent increases. So that's the picture I'm looking for. 0 to 13 pi is one period of the function, and I'm looking for decreasing. So I can get rid of any guy that's increasing, so b is increasing. That would either be cotangent flipped or a transformation on cotangent flipped or tangent, depending on the transformations you want it to write. I know the numbers are really small here, but this one, I see 2 pi here, and that would be the 2 periods of the function, so that one's definitely not right. Same thing down here, I have 1 period of the function down here is happening at 2 pi, so nope. Here I see 26 pi, that means that this would be 13 pi, and that guy is matching the pattern that I'm recommending. So your answer is C. Whoops. All right, that's trig graphing review.